Welcome to the EEE360 video for lab number 8. In this experiment, we'll be using the power supply, the transformer, the voltmeter, and a handheld ammeter, as well as a low power factor wattmeter. And here we have the inside of the transformer module. Here is the iron core. And around the iron core, underneath this bobbin, underneath that white bobbin there, we have several windings. And the windings, we can see the connections come out here on the top as well as along the bottom. And all of the windings are protected by fuses shown here, and these fuses help protect from overcurrent. And here's the front of the transformer module. We can see that the connections between 1 and 2, this winding here, that entire winding is the secondary winding rated at 120 volts. And the primary winding is connected between 3 and 4. Again, this entire winding here, that is the primary winding. And if we total up the total of those voltage readings, they total to 208 volts. And again, the entire winding is between 3 and 4. For this lab, in the hardware lab, we have to use a special type of wattmeter known as the low power factor wattmeter. And we'll be making the connections based off of what current rating we're going to be doing. And there's a 1 amp and a 0.2 amp. We're going to be using the 1 amp connection. There's also different voltage connections, as the 120 volt connection, as well as a neutral point. In your lab, you're not going to have to use a low power factor wattmeter. You'll just be using the digital wattmeter provided. For this meter, we can read the watt meter directly off the top. In this next shot, we're going to show you an important factor that we're going to have to take into account when making measurements using this device. Here's an important note about this low power factor wattmeter. We're going to have to multiply the value that we get off the scale by a different factor. We're going to be using the 1 amp connection as well as the 120 volt connection. So we're going to have to take any value we get from the screen and multiply it by 0.2. For this lab, we'll also be using the handheld ammeter. In order to use the ammeter, we're going to turn on the selector switch till it reads the milliamp reading, and we're going to make connections at the common node as well as the milliamp node, and we'll be connecting this in series as we do all ammeters. And now we're ready to perform the open circuit test. When you do this lab on the computer, you're going to be performing the open circuit as well as the closed circuit test in order to get the entire equivalent circuit of the transformer. And now we're ready to make the connections. First, we're going to go from the variable AC power supply into the handheld ammeter, and we're going to connect the handheld ammeter to the number 1 connection on the transformer. Next, we're going to connect the primary side, the secondary winding, into the 120 volt slot on the wattmeter. Now we're going to start the path back to the power supply, the return side. That's going to go from number 2, the other side of the primary winding, into the 1 amp slot. And we're going to make that connection from the 1 amp slot on the low power factor wattmeter into the neutral point. And finally, we're going to connect the other neutral point of the low power factor wattmeter to the neutral of the power supply. The last connection to be made is to check the voltage going into the secondary winding. We're just going to take that voltage directly from the power supply. We'll connect the neutral as well. And now we have all of our connections properly made. And now we're ready to energize our circuit. We'll turn on the power supply. And now we're going to adjust for 120 volts across the secondary winding. And now that we have that voltage set, let's go ahead and check out the rest of our measurements. And here we can see that we do indeed have 120 volts across the secondary winding. And here we can see our current reading. We have 1.03 milliamperes. Here's a close-up of our low power factor wattmeter reading. We can see here that this reads 22.5 watts. Remember, we have to take into account the factor on the front of the wattmeter by multiplying that by 0.2. So our actual reading is 4.5 watts. And now, students, it is your turn to make this experiment as well as the short circuit test as outlined in your laboratory manual.